Hi guys, welcome to my channel. In this video, I will be covering what is point-to-point protocol, connection phases of point-to-point protocol. We also call this connection phases as transaction phases. Next, I will explain point-to-point protocol frame format, and also I will explain what is DSL, that is digital subscriber line, what is asymmetric DSL and symmetric DSL. I will explain all these topics in detail. Guys, I have uploaded complete computer network subject tutorials. I will provide that link in description. You can watch from there. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. At first, I will explain what is point-to-point protocol. Point-to-point protocol is a method used to connect two computers or devices directly so they can exchange data. It is like a private conversation between two devices. A computer connects to the other computer using a cable, or a computer connects to the internet through a telephone line. Point-to-point protocol makes sure the connection is proper, secure and error-free. By using point-to-point protocol, we can connect only two devices in order to exchange data. For example, I want to send some files to my friend computer. So I will connect my computer with my friend computer directly by using cable. And then I will transfer files to my friend computer. As only two computers are communicating directly by using cable, this connection is private connection because no one is involved. So by using point-to-point protocol, two devices can communicate each other properly, securely and as well as error-free. There will not be any errors in data transfer. Next I will explain connection phases of point-to-point protocol. Guys, there are total 6 phases in point-to-point protocol. I will explain each of them. And the first phase is dead phase. In dead phase, nothing is happening. No data is being sent and the devices are not connected. The connection link is inactive. Thus in dead phase, there are two computers, but these computers are not connected to each other and they are not transferring data. As there is no communication link between these two devices, communication link is inactive. This is dead phase. And second phase is established phase. One device wants to start a connection, so it activates the link. It sends a request to other device using LCP, that is link control protocol. If both agree, the connection moves forward. Thus for example, this computer wants to send data to this computer. This computer will connect to this computer by using cable directly. Before this computer sending data to this computer, at first this computer will send request. So if this computer accept request, then they both can communicate each other, like they can transfer data. And this computer will send request to this computer by using link control protocol. And third one is authentication phase. Sometimes the devices may need to verify each other's identity. They do this using passwords. If authentication is successful, the connection continues. If authentication fails, the connection is terminated. This computer wants to send data to this computer. Before that, they will verify each other. Like this computer will enter password like 123 and same this computer also enter password 123. If both passwords match, then connection is successful. They both can communicate each other. For example, this computer will enter 123 and this computer will enter 456. As there is no password match, connection will be terminated. They cannot communicate each other. And fourth phase is network phase. In network phase, devices need to decide what kind of data they will send. Since PPP support different types of data, they also need to decide which protocol they will use, like IP or IPv6. Thus normally we will send different types of data like images, PDF files, songs, videos, etc. So in network phase, devices need to decide what kind of data they will send. By using point-to-point protocol, we can send different types of data. And in network phase, they also need to decide which protocol they will use, like either they will use IP or IPv6. And systems will decide all this by using network control protocol. This is all about network phase. And fifth phase is open phase. In open phase, devices will start sending and receiving actual data. Guys, how much time devices communicate each other, that much time communication link is active. Communication link is nothing but wire. Guys, data is successfully reached to this computer. Now devices want to end communication. So if devices want to end communication, they need to move to terminate phase. When one device decides to end the connection, it sends a termination request. Guys, for example, this computer will send request to this computer in order to close connection. And acknowledgement is nothing but acceptance. This computer will accept termination request of this computer. So now connection is removed and both computers cannot communicate each other. Once connection is removed, device will go to first phase, that is dead phase. Guys, these are connection phases. We also call them as transaction phases. So dead phase, no connection is established, and in establishment phase, connection will be established between two computers. Thus, authentication phase is not mandatory phase. If devices want to verify each other, they will send passwords, and some other device will communicate each other directly without any passwords. If devices don't want to verify each other, directly they will go to network phase, and if devices want to verify each other, they will go to authentication phase. In authentication phase, they will verify password. If there is password match, so authentication is successful, they will go to network stage. And if authentication fails, computers cannot communicate each other, so directly they will move to terminate phase. And in network phase, computer will decide which data they want to send, either photos or PDF files or movies or etc. And they will also decide protocols, whether IPv6 or IP protocol. After network phase, device will move to open phase. In open phase, devices can communicate each other by sending and receiving actual data. Once data transfer is successful, connection will be removed. In termination phase, one computer will send request to other computer in order to remove connection. If other computer accepts that request, then connection will be removed. And if connection is removed, then device will go to dead phase, as they are not connected to each other. These are various connection phases in point-to-point protocol. Next, I will explain point-to-point protocol frame format. Thus, frame is like parcel. For example, I purchased one product in Amazon. So what they will do is, they will place that product in parcel and they will give me. Similarly, if one computer want to send data to other computer, it will not send the data directly. Instead, this computer will place the data in frame and then it will transfer data. So frame is like parcel. Point-to-point protocol uses a frame format to ensure proper communication between two devices. Each frame contains different fields and each field has specific purpose. The structure of the point-to-point protocol frame is given below. Thus, point-to-point protocol frame contains various fields and each field will perform certain tasks. Thus, for example, I want to send hello message to my friend by using point-to-point protocol. So this hello message is considered as payload. So payload is nothing but actual data which I want to send. And at starting and at the end, we will place flag. I will explain what is flag. Thus, flag size is 8 bits, like 1, 2, 3, 4, 5, 6, 7, 8. Like that, flag size is 8 bits. We also call 8 bits as 1 byte. So in place of writing here 8 bits, you can also write here 1 byte. So flag size is 1 byte. Flag is marked at the starting and ending of the frame. This flag will indicate beginning of the frame and end of the frame. And flag value is always 0, 6 ones and 0. This is default value. This value will not change. If any device want to send data, by default, this is flag value. And this flag value is used to identify starting and ending of the frame. So by seeing this flag, receiver device can identify starting and ending of the frame. And second field is address field. This is also 8 bits. Just for example, this computer want to send data to this computer. So what this computer will do is, in this frame, this computer will include address of this computer. And default value is all ones. So 8 bits, total 8 ones. Guys, 8 bits are nothing but broadcast address. That is nothing but, by default, whenever this computer include all ones, that means data is transferred to all computers connected to this network. Though data is sent to all computers, only particular receiver will receive the data. So only this computer will receive the data. This is meaning of broadcast address. So by using address field, sender will identify receiver device and its value is always ones. And all ones are broadcast address. That means data is sent to all devices connected to network. And third field is control field. And here also there is default value, that is 00000011. This is default value. This control will define frame type. It specifies how the frame should be handled. It decides whether the frame need acknowledgement or not. It tells the receiver what kind of message it is. It treats all frame in the same way. Guys, whatever data we send by using point-to-point protocol, this control will treat all messages in same way. That is why we will include 6 zeros and double ones, total 8 bits. So for each and every message, control is same. Guys, for some important messages, receiver should reply. And for some other messages, there is no need of reply. So this control will decide whether receiver must send acknowledgement or not. Acknowledgement means reply. And fourth field is protocol. The protocol field in PPP frame tells the receiver what type of data is in the frame. Guys, normally we will send two types of data. One is IP packet. IP packet is nothing but Any message that is sent by using internet is known as IP packet. For example, I will send a message hello to my friend. So this hello message is considered as IP packet. So normally we will send two types of data. One is normal IP data and next one is login verification. Whenever we enter username and password and click on login button, receiver must immediately give response like whether user is correct user or not. So protocol field verifies whether data is internet data or login data. If data is internet data, then it will include value like 0x0021. For example, if this data is login data, then protocol field contain value that is 0xC023. So based on these values, receiver will identify what type of data is present inside the frame. Whether data is IP data or login verification data. And protocol value is not 1 byte, it is 2 byte, that is 16 bits. And fifth one is payload. Actual data that is present inside the frame. We call this actual data as payload. And size can be up to 0 to 1500 bytes. Normally point-to-point protocol will carry two types of data. One is IP packet, that is nothing but internet messages. And next one is login verification data in order to verify users. And sixth one is checksum. Yes, for example, I will send message hello, but receiver will receive data like JELLO. In place of H, he will receive data JELLO. So by using checksum method, we can identify errors. And checksum size is 2 bytes or 4 bytes. Next I will explain what is DSL, that is Digital Subscriber Line. Digital Subscriber Line is a high-speed internet technology that uses telephone lines to provide internet access without interrupting voice calls. It allows users to access the internet while making phone calls on the same line. Yes, normally if you consider Airtel Jio, but actually in olden days, they are only telephone lines. We can only do phone calls by using Airtel and Jio. But at present, by using Airtel, we can do phone calls and as well as we can access internet. So this Airtel and Jio, both are examples of digital subscriber line, where we can do both voice calls and as well as internet access. They will use single cable. So this single cable will provide both voice calls and as well as internet. As we are accessing voice calls and internet in only one single line, even though there will not be any interruption. So DSL will allow users to access internet and as well as phone calls on same line, that is by using single cable. Digital subscriber lines are classified into two types. They are asymmetric DSL and symmetric DSL. Guys, whatever the internet we are using in our house, that internet is ADSL, that is asymmetric digital subscriber line. As for example, by using my Airtel internet, I want to download movie. So simply within 10 minutes, I can download movie. For example, I want to upload movie in internet. So it will take long time in order to upload movie. So in ADSL, there is more download speed when compared to upload speed. Whatever the internet we are using in our house, we call that internet as asymmetric digital subscriber line. And next one is SDSL, that is symmetric digital subscriber line. As whereas in ADSL, there is more download speed when compared to upload speed. But whereas in SDSL, download speed and as well as upload speed, both are equal. Normally software companies will take HDSL. Guys, for example, if Geo towers are near to our house, then internet will be very fast. And if Geo towers are far away, I will get slow internet. So internet service providers like Jio, Airtel, Active FiberNet, if they are near to our location, internet will be fast or else internet will be slow. Guess ADSL and as well as HDSL, both are full duplex. Full duplex is nothing but all computers can send data and receive data at the same time. Next I will explain how ADSL works. ADSL contains two types of devices. They are splitter and ADSL modem. I will explain what is use of these devices. As I already said before, data and voice calls both are traveled by using single cable. So whenever data and voice calls are traveled by using single cable, splitter device will take that voice calls and data and then it will separate voice calls and data. Splitter device contain low pass filter and high pass filter. These filters are electronic components that are present inside splitter device. Low pass filter will take low frequency voice calls and then it will block high frequency data. And similarly, high pass filter will take high frequency data and then it will block low frequency voice calls. So low pass filter will take only voice calls and high pass filter will take only internet data. Because of low pass filter and high pass filter, there will not be any noise in voice calls and data transfer. Whenever high pass filter take internet data, further it will transfer that internet data to ADSL modem. Guys, ADSL modem is a device. It will perform two operations. They are modulation and demodulation. For example, I will send message hello to my friend. It is converted into zeros and ones. So ADSL modem will perform modulation. That is nothing but converting our binary data into analog signals. Analog signals are nothing but continuous waves. So converting our binary data into analog signals is known as modulation. So ADSL modem will perform modulation and it will also perform demodulation. That is nothing but converting analog signals back to binary data. So receiver will read the data. So converting analog signals back to binary data is known as demodulation. ADSL modem will perform these two operations. This is how ADSL will work. So whenever voice calls and data both are travel in single cable, splitter device will take voice calls and data, and in splitter device there is low pass filter and high pass filter. Low pass filter will take only voice calls and it will block internet data, and whereas high pass filter will take only internet data and it will block voice calls. That is why Airtel, Jio, BSNL all are providing internet and voice calls without any interruption. And further, internet data is transferred to ADSL modem, which will perform modulation and demodulation. Converting binary data to analog signals, that is continuous waves, is known as modulation. Converting our analog signals back to binary data is known as demodulation. This is how ADSL works.